Okay, so basically this is like a part 2. This is an extension of the Edpuzzle that we did the other day on absolute value, right? So I'm going to give you a really brief description of absolute value because the other video has a more in-depth one. But ultimately, what we're talking about with absolute values, so if I had like the absolute value of x equals a, right? We're saying that we have a distance, right? We're saying that whatever this is inside here, in this case it's x, it's going to be a distance from 0 on a number line. We're saying it's a distance of a away from 0 on the number line, which is why when we pull the insides out of the absolute value, they always are positive because you can't have a negative distance, right? We're just saying that when it's negative, it's a distance in the negative direction. When it's positive, it's an a distance in the positive direction, right? But it's still just a direction. And a couple things you need to understand is if I have, say, the absolute value of x, and you guys, when you watch the other video, you'll be like, oh, this looks familiar, is 7, right? The absolute value of x is 7. They're saying, what values of x will make this true? Well, because it's always positive when it comes out of the absolute value, we've got 7. Well, 7 would equal 7, right? But also the absolute value of negative 7 would equal 7. So because of this, when we set up an absolute value problem, you have to set up 2 equations, one to the negative, one to the positive. A little rule of thumb that I want to mention is if I have an absolute value, say I have the absolute value of x equals negative 7, if an absolute value is all by itself on one side of the equal sign and it's set equal to something negative, you're not going to have a solution, right? Because if I plug in, say, 7 into this, when I pull it out of the absolute value, it's always going to be positive, right? So 7 does not equal negative 7. If I put in negative 7 in here, equals negative 7, sorry. When I pull this out of the absolute value, it's still going to be positive, and it does not equal negative 7. Does that make sense? I'm going to assume that's a yes because nobody's answering me. So we're going to talk about really quickly what are the steps to solve. And the steps, I'm going to abbreviate them because I used them in the other video in depth. So I'm just going to go isolate. And that is to isolate the absolute value on one side of the equal sign. 2, create 2 equations. One will be set equal to the positive and the other will be set equal to the negative. But again, I'm going to show you how to do all of these, and they're in depth in the other video. Then solve both equations. And then the last one is check for extraneous solutions. Check extraneous. An extraneous solution is a solution that does not work when you put it back into the original problem. And sometimes that will happen. So if we're going to look at it in terms of simple equations, just to run through one, if I have the absolute value of x minus 9 equals 5, right? The first step it said was to isolate the absolute value. And that means that on this side of the equation, the only thing that can be there is the absolute value and what's inside it. So this is already isolated. We don't have anything multiplied to the outside of it or divided or added to it. So it's already isolated, right? We already know all we want to know is what this absolute value thing equals, right? So the next step was to create two equations. The first equation, you're going to take the insides, x minus 9, and set it equal to 5. The second equation will be x minus 9 equals negative 5, right? And then we're just going to solve both equations. So to solve, I'm going to add 9, and I get x equals 14. And here I'm going to add 9 and add 9, and I'm going to get x equals 4. These are my two solutions. Now, the fourth step is to check for extraneous solutions. I just mentally do it most of the time, unless the problems are super big, the original equation. But I can just look at this and I go, okay, well, if I put in 14 where this x is, right? Let's see, I can do that. If I put in 14 there, I have 14 minus 9, which is 5, and the absolute value of 5 is 5. So these two equal. If I put in 4, 4 minus 9 equals negative 5, but the absolute value of negative 5 is positive 5. So I know it works, and you can just kind of do a run through. Usually when it doesn't work, it'll kind of make itself pretty obvious. And that's the only really simple problem I'm going to do, because I do a bunch of them in the Edpuzzle video. So, and what I wanted to show you was some more complex stuff before we did it, for you to have when we get to it. I wanted to hit you with a couple of division and multiplication things that you were going to have to do to isolate the variable when you have to actually work. So we're going to go with our example here. Ooh, I like that blue right's big. I mean, I know I could change it so that they all do that, but I just kind of like it. So I'm gonna do the absolute value of x minus 10 over negative 2 equals negative 6. Now, I know I said that when an absolute value equals a negative, that there's no solution, but we haven't isolated that absolute value yet, and we can't tell until the only thing on the other side of that equal sign is the absolute value. So what we're going to do is we have this equation divided by negative 2, right? And when we want to clear a fraction, if we want to get rid of a denominator, since it's technically division, we just want to multiply. So we're going to multiply the numerator times negative 2, but we also have to multiply the other side by negative 2, because you can't do something to one side and not do it to the other. And what it does here is it gives us negative 2 over negative 2, right? And that just makes 1, so we can cancel it out entirely. And I'm left with the absolute value of x minus 10 equals negative 6 times negative 2 is positive 12. And so this is a solvable equation, right? Because it's still positive. So now that we have the absolute value isolated, so it's the only thing on the side, that side of the equal sign, we're going to go ahead and set up our two equations. We are going to have x minus 10 equals 12, and we're going to have x minus 10 equals negative 12. And then we can go ahead and solve each problem. So I'm going to go plus 10, and I get x equals 22. And then I'm going to go plus 10 and plus 10, and I'm going to get x equals negative 2. And I can look at this original equation, even though I've played with it enough that it's all ugly. And I can plug in negative 2 here. Minus 2 minus 10 is minus 12 divided by minus 2 is positive 6. Well, actually, when I pull it out of the absolute value, this becomes positive 12. Divided by negative 2 is negative 6, and negative 6 equals negative 6. I could do 22 minus 10 is positive 12. And when I pull it out of the absolute value, it's still positive 12. Divide by negative 2, it's negative 6. So I see that both of these work. If you can't do it in your head, just take it off to the side, do a little whiteboard, scratch paper, whatever, and plug the number in and see if it works. All right. So this is the first one. This is a division problem. I've got a couple of special case problems that I want to show you. Let's do like that. So we're going to do another couple examples, and it's just so that you can see I really like the color blue in every shade. I love the color blue. If I have 16 times the absolute value of x minus 5 equals negative 32, this absolute value is not isolated. It has 16 multiplied to it. So we have to do the opposite of multiplication, right? Which is division. And so we need to divide this side by 16 and divide this side by 16. And these will cancel out because they equal 1. And I have the absolute value of x minus 5 equals negative 2. And remember what we talked about earlier, if we have the absolute value by itself equal to a negative number. Does anyone remember what happens then? Absolutely. Perfect, Emily. There is no solution. So you don't have to set up the equations now. You don't have to do any of the other stuff. You could just write no solution. All right. I just wanted you to see what one of those look like. The last thing I wanted to show you is another division problem. So the final example. You guys are on the final example right now. It's the best problem of the day. You know, I know it's the best problem of the day. It's the last problem of the day. Plus 12. Ooh, that's ugly. Divided by 9 equals 0. Right? And we did a division problem earlier, right? And if you remember when we did it, we want to clear that fraction. Do you remember how to clear the fraction? Yeah, by the denominator, right? So I'm going to take this, I'm going to change color so you can see what I'm actually doing to it as opposed to the original equation. I'm going to multiply this by 9, and I'm going to multiply this side by 9, right? So I got to do it to both sides. These will cancel because it's just 9 over 9, which is 1. And I'll be left with the absolute value of 3a. It looks like I wrote 13a, but it's the absolute value of 3a. Plus 12 equals, well, 0 times 9 is still just 0, right? So now we have it isolated, right? Everything on that one side is the absolute value, but it's set equal to 0. And so technically now we're supposed to create our two problems, right? One set to the positive and one set to the negative. But what is negative 0? Yeah, it's just 0. So you're only going to have one solution. So if it's set equal to 0, you only need one equation, right? And when we do it, then we just solve it out. And I'm going to go minus 12 because remember we do backwards PEMDAS when we're solving equations, the inverse. So we've got 3a equals negative 12. And then we can divide by 3. Divide by 3. I'm going to have to scooch it up just a little bit. I almost had enough room. Our 3's are going to cancel. And we will have a equals negative 4. And that will be your only solution for this, right? What do you mean? Where it says 3a plus 12 equals 0, because that's what's inside, isn't it? 3a plus 12. Oh, that's the absolute value line. That's my bad. That's just an ugly drawing. It should just be the absolute value line that goes straight up and down. That's my bad. It's not 13a, it's 3a. Yeah. That was just my terrible use of the tablet drawing that messed that up for you. But does that make better sense now? So it was always 3a. I just wrote it ugly. Okay. Well, that's technically the last problem I have for you. Oh, you know what? Actually, I lied. I'm going to do one more problem because someone brought up in my class yesterday. He had gone through and done the homework already. And there was one problem where it had variables on both sides. And it really is something that you should know. So I'm going to do one more quick example for you to see, because he said there were a couple of them in the homework. And I want to make sure that you understand how to do it. And I will try and write it prettier this time. So we've got minus 4x minus 2 equals the absolute value of 6x plus 20. So right now we already have an isolated absolute value, right? We have that 6x plus 20. It's the only thing on that side of the equal sign. I'm going to rewrite it on this side just because I like to have what I'm solving for on the left. It's a personal preference of mine. You can still work from both ways. But to me, it helps me keep it straight in my head when I'm doing things like this. So right now, when we're doing a problem like this, every time we've got that isolated absolute value, is the only thing on that side, we're supposed to set it up to two equations, one positive and one negative. So we've got 6x plus 20. And our positive, even though we're starting with a negative here, is going to be negative 4x minus 2, because that's what it is, right? That's all we're setting it up to, is exactly what's there. The other one we set up has to be 6x plus 20 equals negative, create a grouping, minus 4x minus 2, because we have to run that negative through the entire grouping when we're solving it. All right. And that's why I specifically wanted to show you a problem like that, because he said that there are a couple in the homework. And now we're going to combine our like terms. I'm going to move all of our variables to the left side because that's where I like them. So I'm going to add 4x and I'm going to add 4x here. And I'll be left with 10x plus 20 equals negative 2. And then I'm going to move my 20 over. I'm going to subtract 20, and I have 10x equals negative 22. And then we just divide by 10, divide by 10. And I get x equals, I cannot leave it in good conscience as negative 22 over 10. The math teacher in me will not allow me to have an even number over an even number in a fraction, because I know I can divide them by 2. So it's going to be negative 11 fifths. This last one, though, this is where I really want you to see what we have to do. When we do this, we have to distribute. So we'll have our 6x plus 20 equals. Then we have to distribute this negative, right? We have to multiply each piece times negative 1. And it just changes the signs. So this would be 4x. And then when I distribute it here, this becomes plus 2. And then we follow the same steps, right? We're going to combine our like terms. Here I'm going to subtract 4x this time, though, because now it's positive. And I get 2x plus 20 equals 2. And then I'm going to subtract 20. And I get 2x equals negative 18. That's an ugly x. Let's make that prettier. And then we're going to divide by 2. And I have x equals negative 9. So these are my two solutions, right? And the main reason I wanted to show you is so that you understand that when you set it to the negative, you have to set that entire thing that it's equal to the negative. So you're going to have to make a grouping and then distribute that negative to each part, which will ultimately just change the sign of each part in the grouping. Okay, that should wrap it up for you. I don't think that we have anything else we need to go over. As long as you guys don't have any questions, I'm going to go ahead and stop my recording.